Hi everyone. Today we are going to start the last part of the chapter alcohols, phenols and ethers. So we have completed phenols, we have completed alcohols, and now it's going to be the last part, that is the ethers. So in this video we'll try to discuss some important aspects of ethers, including the structure and including the some physical properties and a little bit about classification and the nomenclature. Okay, so what are ethers? These are the organic compounds which have oxygen between two R groups. Okay, so when oxygen is surrounded by two R groups, this R we will discuss can be, this can be alkyl groups, this can be aryl groups, or it can be either of the two. Okay, so when the oxygen is directly attached to two R groups, then we call these organic compounds as ethers. Okay, so the general representation of the ethers is, this is the general representation. Okay, R O R dash. So we have R which is attached to oxygen, and the oxygen is attached with another R group. Okay, so this is the general representation of the ethers. Now this R can be this can be the same, these two R's can be the same alkyl groups. Okay, R can be equal to the R dash and can be an alkyl group. This R can be equal to the R dash, and this can be an aryl group. Okay, aryl group means it can be an aromatic system, or the one of the R's, one of the groups, one of the R groups can be an alkyl group, and another can be the aryl group. Okay, we'll look at all examples of all these types. So these are the different combinations that these two R's can have. So in ether, actually the main thing is that the oxygen is bonded to two carbon atoms, and these two carbon atoms belong to any of these combinations. Okay, so if we try to look at the structure of the ether, there exists a bond angle of about 104.5 degrees. Okay, this is the bond angle, and there may be a slight difference between different ethers, but this is the most general that we're representing here. Okay, and also we have the bond length between the RO. This bond length is equal to 140 picometers. Okay, this is a simple representation of what we can say the ethers. So just as oxygen atom in water forms a bridge between two hydrogen atoms, in a similar way oxygen atom in ethers form a bridge between two alkyl groups or two aryl groups, or any of the combinations that we have discussed here. Okay, so this is the general introduction of the ethers. Okay, now we will discuss the classification, and we'll try to look at the different examples of ethers. Okay, so ethers can basically be divided into two types. One's symmetrical or unsymmetrical. Okay, or we can also, symmetrical is also known as a simple ethers, and the unsymmetrical one we call as the mixed ethers. Okay, so if the R groups attached to, if the R groups attached to oxygen in the ether, if these two R groups are same groups, okay, if these are same groups, then we call the ethers as a symmetrical or simple ethers. For example, if we have CH3O CH3, okay, So the both R groups are the same groups. Okay, we have CH3 group and the CH3 group. Now this ether becomes the symmetrical ether. Okay, we can take another example. For example, we have uh, CH3 CH2 O CH2 CH3. Okay, again we have ethyl group and ethyl group on the both sides of this oxygen. So again this is the symmetry. This is example of the symmetrical alkene, symmetrical ethers. Again these R groups can be aryl groups. In these two examples we have taken the alkyl groups. This is the alkyl group, this is the alkyl group, and we can also have the aryl groups across the oxygen. Okay, for example, we have two benzene rings attached to this oxygen. Okay, now these are the two R groups. This is R and R. Okay, these are the two R groups, and both of them are same. Again, this is the example of the symmetrical ether. Okay, so these are the simple examples. We'll look at the nomenclature, how we name these ethers. We'll look that in the upcoming slides. Okay, so no need to worry about that. Now what are the mixed or unsymmetrical? In mixed or unsymmetrical ethers, these two R groups are different. Okay, these are different. There is a combination. These can be two different alkyl groups, or two different aryl groups, or they can be one of them can be an alkyl group and another can be the aryl group. For example, let's take the example. If we have CH3O CH2CH3. Now we have ethyl group from this side and we have methyl group from this side. So this is the unsymmetrical. This is the unsymmetrical what you call as the ether. Okay, we can have an example like this. We have OCH3 and one of the benzene rings is attached to this side. Again this becomes the unsymmetrical, an example of unsymmetrical alkene. Okay, so these are the different examples that we can have. We can take one more example. For example, we have C6H5. C6H5 this is again this ring. Okay, we can represent this ring as C6H5, that's attached to the oxygen, and then we have CH2 and C6H5. Okay, we have two aryl groups, different aryl groups that are attached to this oxygen around this that are attached to this oxygen. Okay, now this aryl group is different and this aryl group is different. So these are the examples of the what you call as mixed or unsymmetrical ethers. There's one more way of classifying the ethers. We can classify ethers as aliphatic ethers and the aromatic ethers. And aromatic ethers can again be further classified as phenolic or alkyl aryl ethers or diaryl ethers. Okay, so if we look at the aliphatic ethers, these are those ethers in which we have only alkyl groups. Okay, there are no aromatic, no aryl groups attached to the oxygen. Now again we can have different examples in this case. Okay, we can have this may include symmetricals and as well as unsymmetrical ones. Okay, for example, we have CH3OCH3. Okay, there are two alkyl groups attached to oxygen. These are the aliphatic chains. Okay, we can have CH3CH2OCH3. Again, there are the alkyl groups attached across this oxygen. So these are the examples of aliphatic ethers. We do not find the attachment of any aryl group, any aromatic group to the oxygen. Okay, so such examples belong to the aliphatic ethers. Okay, and talking about the aromatic ethers are those ethers in which we have the we can have aromatic means the aryl rings, aryl groups are attached to the oxygen, across oxygen. Okay, we can have one aryl group, or we can have more than one aryl group. So if we have, for example, one aryl group in the ether, then we can take an example. For example, we have we have a oxygen that's attached to a benzene ring C6H5. Okay, and from other side it's attached to CH3. This is an example of phenolic, or this is alkyl aryl ether. Okay, we have one alkyl group and another group is aryl group, so this belongs to the phenolic ethers or alkyl aryl ethers. And if we have two aryl groups attached across this oxygen, okay, C6H5, C6H5. So we have two benzene rings that are attached to the oxygen. These both are aryl groups. Okay, so these are two aryl groups. That's why they are diaryl ethers. Okay, so this is the just simple classification of ethers which we have to keep in mind. Okay, so that just we have to understand the attachments of the groups across this oxygen. There are simple things that we have to remember. Okay, now coming to the the nomenclature, how we name the ethers. There are two systems of naming. One is the common system of nomenclature. Okay, and another is the standard system, that is the IUPAC system of nomenclature, that we use for the nomenclature naming of the organic compounds. Okay, so in common system, if we have for naming of ethers in common system, in case of symmetrical ethers, if we have symmetrical ethers, then we use the prefix di. Okay, for example, if we have the oxygen attached, we have two CH3 groups. Okay, now this is an example of symmetrical ether. Okay, because both groups attached to this oxygen are same. To name these symmetrical ethers, we use the prefix di. So how we'll name this? We will say that this is dimethyl. It is dimethyl, means there are two groups. There are two groups, two methyl groups. We have dimethyl ether, dimethyl, and this part will be named as ether, dimethyl ether. Okay, another example, if we have for example, we have CH3 CH2 O CH2 CH3. Again, this is a symmetrical ether. We have similar groups that are attached to this oxygen. Now we have again to use the prefix di, so we can say it is di. Now these groups are ethyl groups, so it is diethyl ether. It's diethyl ether. So this is how we name the symmetrical ethers in common system. And for the unsymmetrical ones, two alkyl or aryl groups that are linked to oxygen atom are named in the alphabetical order. And then last we use the word ether to them. Okay, for example, let's take the example for the point number 2. In case of unsymmetrical alkenes, for example, we have CH3. We'll take simple example, CH3O CH2 CH3. This is unsymmetrical ether. We have ethyl group from this side and we have methyl group from this side. Now we have to use the alphabetical order for naming it. So the name of ether starts with E, and that of the methyl starts with M, and M comes first, and the E comes first, and that's followed by the M. Okay, that's so to name this, we'll first name this part of the ether, that is, we'll say it is ethyl, then we have methyl, then it's ether. Okay, we have ethyl, methyl, ether. Another example we can take for example, for this category we can take of an aryl system. If we have oxygen that's attached to two benzene rings, okay. Now this is diphenyl ether, okay. It is, we have two phenyl groups, that's why it is diphenyl ether. It's diphenyl ether, okay. We can have many more examples to name different uh, symmetrical and unsymmetrical ethers by the common system, okay. Particularly we have some very famous ethers that we use in many organic reactions that belong to that we name by the common system, and they are known by the common names mostly, okay. For example, we have an ether in which we have a benzene ring, okay, and we have a methyl group. So in this system, the oxygen is attached to a benzene and a phenyl ring and a methyl group, okay. So this is a very common ether which is called as anisole. This is a flavoring agent, okay, we used in many perfumes, pharma industry, okay, pharma, perfumes, and all that. Similarly, we have one more common, what you call as the ether, that is furan. You must have heard about the name. This is a very good solvent that we use in many organic reactions. And also we have tetrahydrofuran also, and this is another ether which is also important in many respects in organic chemistry, okay. So these are some famous ethers that are used in many organic systems, okay. They belong to ethers, and this is the common system of naming them, okay. Now if we talk about the standard system of naming, that is the IUPAC naming, International Union of Pure and Applied Chemistry system, okay. So here the ethers are named as alkoxy ethers. They are named as alkoxy ethers. The alkyl or the alkyl group that's attached is given the name alkoxy. For example, methoxy, ethoxy, okay, and then the ether. So for example, yes, another point is that the ethereal oxygen is taken with smaller alkyl or aryl group, while the larger alkyl or aryl groups considered to be the part of the alkane. This will be understood by the example. For example, if we have CH3OCH3, this is a symmetrical ether, and to name by the IUPAC system, what we will do, we'll take this oxygen with one of the groups, okay. As the two groups are same in this case, so there is no point of making a difference between them. So we can take this oxygen with either this methyl group or this methyl group, okay. So in this case it will be methoxy, then methoxymethane, okay. So this methoxy represents this part of the ether, and then the methane is this part of the ether, okay. Now let's take a different example. If we have CH3OCH2CH3, now we have two different alkyl groups that are attached to the oxygen. In this case we have to take the smaller alkyl group, we will take that with the ethereal oxygen. This is the ethereal oxygen, okay. Now the smaller one in this case is what? This is a methyl group, okay. So this part will be this smaller alkyl group will be taken with the what you call as the ethereal oxygen, and this is the larger among the two, so it will be considered as the alkane part of the system. So how we will name it? Now this is methoxy. It is methoxyethane. It's methoxyethane. Okay. Similarly, we can take another example. If we have, for example, from both sides we have ethyl groups, then we can say it's ethoxyethane. Okay, we can have a system like this. We can have a system like this. For example, we have CH3O. We have propyl group on this side, CH2, CH2, CH3. Okay, this is propyl group and this is methyl group. So in this case, we'll name this as how. So the ethereal oxygen will go with the smaller group, and this will be the alkane part. So we'll name it as methoxy methoxy methoxypropane. It is methoxypropane. Okay. If we have an example like this, we have CH3, then we have its attached oxygen, and we have CH3. If we have a branched example, in this case, okay, we have a branched example. So what we'll do, we'll take we'll again take the smaller methyl group with the ethereal oxygen. Okay, now the rest part is the alkane part. Now we have to number this chain. Now we have to number the larger chain. This is the larger chain, so it will be numbered as 1, 2 and 3, or we can also number it from 1, 2 and 3. Okay, and the name that we will give to this is that we have 2 methoxy. The methoxy groups attached to the carbon number 2. That's why it is 2 methoxy, 1, 2 and 3, that is propane. We can also name this as 1 methoxypropane. Okay, the methoxy group is attached to carbon number 1 methoxypropane, because we can have different isomers of the propane and the higher alkanes. Okay, similarly, if we take an example of alkyl ether, for example, we have OCH3, and this is attached to a benzene ring like this. Okay, now the ethereal oxygen will be taken with the what you call as the smaller group, that is this. Then we will name it as methoxy. This is methoxy. Now this is benzene part, benzene. This is methoxybenzene. Okay, if we take the example of anisole, as we have taken in the common names, the common name is anisole. In it we have a benzene ring is attached to the oxygen, and to the other side we have a methyl group. Okay, so if we try to name this by the IUPAC system, then this smaller group will be taken with the ethereal oxygen, and it will be named as methoxy. It is methoxy benzene. Okay, this is methoxy benzene. So in the similar way, we can name different ethers. Okay, now talking about the physical properties of ethers. So the ethers, they are relatively having low boiling points. Why? Because they are unable to form the intermolecular hydrogen bonds. Why? Because the oxygen is, there is no oxygen, there is no hydrogen that is attached directly to the oxygen. We have carbons. Okay, the carbons are attached to the oxygen directly. So these are not able to form the intermolecular, means different molecules of ethers are not able to form the intermolecular bonds, hydrogen bonds. Therefore they show the low boiling points relatively. Okay, and also there is a difference between the electronegativity of carbon and oxygen. Okay, this carbon belongs to what you call as the R groups. Okay, so there is a difference between the electronegativities of two, oxygen being more electronegativity. Therefore there exists a very little polarity in the ethers. Okay, so the ethers are a little polar in nature. Okay, another important thing is that these ethers, they are miscible in water. they're easily able to mix completely with water. When they are added to water, they don't form a separate layer. Okay, they don't form a separate layer. They are mixed with water in an efficient way. Okay, so these are some general physical properties. And also some ethers are they are volatile in nature. They are flammable in nature. Okay, they can burn, they are volatile. For example, we have anisole. Okay, we have anisole, we have ethyl phenyl ether, or what we generally name as phenatol. Okay, we have furan. This is furan. Okay, these are some ethers which are also volatile in nature. Okay, so these are some general physical properties of the ethers. In the upcoming videos, we'll be discussing the chemical properties. The We'll be discussing the methods of preparation of ethers also.